2026, researchers discovered a Linux vulnerability that had existed for almost 18 years. This bug could allow an attacker to escape a container and gain root access to the entire system. This vulnerability is called SCTP Phantom. Most developers are familiar with TCP and UDP protocols. Linux also supports another network protocol, CTP, Stream Control Transmission Protocol. It is mainly used in scenarios that require highly reliable communication, such as telecommunication systems and distributed services. In the Linux kernel, SCTP is responsible for handling network connections, data transmission, and connection state management. This vulnerability lies hidden in one feature of SCTP, dynamically changing the connection address. This feature is implemented through address configuration messages. When an SCTP connection is established, the Linux kernel creates some data structures to store information about this connection. When the connection address changes, Linux needs to delete the old data and then create new state. Under normal circumstances, after deletion, all references should also disappear. But here, an error occurs. When handling address deletion, the SCTP protocol uses two different identities for validation and operations. It performs security checks using the packet's source address, but actually performs the deletion based on the address parameter inside the message. An attacker can craft a malicious message to first request the deletion of a legitimate non-source address, causing the kernel to free a block of memory. Immediately after, the attacker sends a wildcard deletion request, at which point the kernel erroneously continues to use the already freed memory pointer. This is the classic use after free. In ordinary applications, such an error might only cause the program to crash, but the Linux kernel is different. The kernel runs at the core of the entire system. If an attacker can control the erroneous memory in the kernel, they may further gain the highest privileges. So why could this bug remain hidden for 18 years before being discovered? Because large software is never a completely new code base. It is more like a city that is constantly being expanded. Decades of code are layered on top of each other. A design that seemed fine at the time may, years later, produce unexpected conflicts with new features.